Yes, we can. Thank you, Megan. Our next presentation is from Megan Terry, who's the service hydrologist in Springfield. I transferred control to you, and she's going to talk about, really a great emerging tool in the Weather Service in Flash, and some of the operational use that they've had in Springfield with this tool. I think this is really gaining a lot of traction, and I think there's a great deal of potential, and we thank you, Megan, for coming on today to discuss this. So go ahead and take it away.
All right. Thank you, Kelly, and thanks, everybody. Now, can you see the one slide or the two slides?
We see a full screen slide of Flash.
A full screen slide. Okay, awesome. That's what we wanted. Okay, so yeah, I'm going to go ahead and give you a quick overview of Flash, the products created in the application, and then some recommendations on how to use them in your flood ops. And I'll be showing some Flash data from a flash flood event that we had a few years ago, and also share a couple of future developments coming along. All right. There we go. Okay. And just to let you know, I did steal some slides from WDTD training modules. They are much better at the graphics than I am. I'm a huge fan. I'm an avid user of Flash, but I'm not involved in the research and development. So I can point you in the right direction if you have any questions about that. So a quick overview of what Flash is. It's an application. You can find it on the web and in AWIPS. And it uses ensemble approach to flash flood detection and short-term flood forecasting. So the main input is the MRMS, radar only QC precip rates, and they go into the system, and all the pieces of how the water is going to interact with the land are assessed in 3 different models. So they're looking at precipitation, infiltration, interflow runoff, storage, routing, etc. So the 3 hydrologic models that they're using are, the first one is called CREST, and that stands for Coupled Routing and Excess Storage. So they're taking that rainfall from MRMS and converting it to components of runoff or infiltration to, better simulate saturation in low-lying areas. The second model is the SAC-SMA, Sacramento Soil Moisture Accounting. That's the one that the River Forecast Centers used. And you'll see some similar output to the CREST, except they do not use a % impervious in their model like the CREST does. So you'll tend to see a slower response to the rainfall. And then the last model is called the hydrophobic. And again, like the SAC-SMA, except there's no infiltration. It just treats everything like runoff. So you're going to see even a quicker response with the hydrophobic. So it's going to be more of a proxy for your worst case scenarios. And then this is a slide from the WDT training, and just kind of highlight some of the good and the bad of each model. And the main points I want to bring up for the CREST, recommend that you use it in your urban areas. The soils are going to saturate. The top layer of the soil will saturate from the top down, so you're going to see a quicker or a hotter response on the streams that it simulates. And it's going to give you a nice first guess for aerial flood coverage. The Sacramento SMA model, again, it's used by the RFCs. You'll see a slower response because it's going to saturate from the bottom up, but it is a nice tool to use for your longer fuse, small stream and larger stream events. And then the hydrophobic, again, it's your worst case scenario because everything's going to run off. It's really a nice tool to use for maybe have an area with a burn scar. Up in north central part of the U.S., they have frozen ground, so everything's going to run off anyway, so it's a good proxy for that. Let me go ahead and forward. The first output that's generated that I'm going to talk about is CREST maximum stream flow. Actually, all 3 models generate this maximum stream flow product. So they're taking the rainfall, putting it in, and then integrating stream flow from 30 minutes prior to 12 hours out in the future. This product's updated every 10 minutes. On the web version, it's going to use cubic meters per second, and in AWIPS, it's going to use cubic feet per second, and the conversion is roughly 1 cubic meter per second is 35 cubic feet per second. And you'll notice that the larger rivers are going to stand out, of course, because they have the higher flow. But what I really want you to focus on is the smeared looking areas. That's simulating overland flow. And those are areas that you'll want to watch for flash flooding because, at least according to the model, you're exceeding your infiltration capacity. The next field that's produced is called unit stream flow. So it's normalizing the maximum stream flow and then normalizing it to your basins. But the main thing to take away from this is that you're going to watch areas that have a value of 1 or greater on the web version or 100 or greater on the AWIPS version. And so what it's saying is that, in maybe like this area in southeast Kentucky, you'll see values around 2 to 3. So it's telling you that your stream flows in that area are 2 to 3 times what they normally would be. So that may be an indication that you're having some flash flooding in that area. And again, all 3 models are going to generate this. It's updated every 10 minutes. And the spatial resolution on all of these is approximately 1 kilometer by 1 kilometer. And then just to do a quick comparison between the CREST model unit stream flow and the hydrophobic. Again, you'll note that you're going to get quicker runoff, so you're going to get much more of a response in here. So if you have saturated soils and then you have a big rain event come over, you may start seeing unit stream flow hitting, 6, maybe up to 10 times the normal flow. And again, that should be kind of a red flag to you that you need to monitor that area for flash flooding. It also generates soil moisture. Only the CREST and the SAC SMA do that because hydrophobic assumes you're 100%. But anyway, it's a nice way to capture maybe those areas that have been receiving heavier rainfall. And they'll stand out as, actually those areas 50% or greater are those locations that you're going to be wanting to monitor for flash flood potential. And we found that this is a really nice tool to use before an event starts. You're expecting heavy rain. You're maybe trying to, assess where you want to put your watch. I think this is a really good tool for that. And again, just a quick comparison, the CREST is always going to run a little bit hotter than the SAC SMA because of the way the field is saturated. Now, a couple of other tools aside from the stream flow and the soil moisture, this product is called the Precipitation Accumulation Return Period. So what it's doing is it is comparing rainfall frequency data from NOAA 14 Atlas to your rainfall estimates, your MRMS QPE. And when you do that comparison and you start seeing higher values, the units are in years, it's going to answer the question, how rare is that particular rainfall event? So the sample here, I've got a 3-hour rainfall. This was March 14th of 2016. And so for 3 hours, these areas that are in pink are getting a rainfall comparable to a 50-year type rainfall event for 3 hours. So again, another red flag, and this occurring in an urban area, some high potential for flash flooding there. So it will generate this for durations of 30 minutes, 1, 3, 6, 12, and 24 hours. And it also generates a composite product called Max PRP. So it won't tell you which field it's taking it from. It just goes through all of them, picks out the maximum, and plots that on. So I think that would be a really nice situational awareness tool for you. And the last product that I'm going to talk about is the ratio of QPE to flash flood guidance. So again, that's pretty much straight up comparing your rainfall to your flash flood guidance. And it generates that comparison for 1, 3, and 6 hours. And it also does a maximum comparison field, like with the QPE to average return intervals there. And so we see values for that same time period and event. We're exceeding flash flood guidance by a factor of 2 here in downtown Springfield at this time. So just to give you an idea of what happened in that particular event, looking at that data, we had some swiftwater rescue people who got to put their skills to practice that night. So it was just an evening, Saturday evening from 6 to 9. Parts of Southeast Springfield got 6 inches of rainfall. And I think using this tool is kind of a heads up to, hey, you know, you may have a big problem here, even a very small area, and it might kind of, you know, being such a small area might catch you off guard. So again, the flash products are available in AWIPS, and it's a little tricky. You need to we go through the MRMS menu, but there are actually 2 flash options. You need to pick the second one. So here's what, you know, it would look like for our area. So you go to not flash products, just flash, and then you're going to have all those products listed there for you to use. And again, they all update every 10 minutes. Now, with the last build or so in AWIPS, there have been some issues with the color curve displays. So you may have to go in and tinker with those a little bit, but I would recommend until they totally get those fixed that you use the web version. And you might have to manually update it, but the color curves will be right. I know for this, if you go into either right click and do change color map or imaging, that you can get to some different color curves that may work for you. And average return interval sometimes can get lost whenever you do an upgrade. And, you know, I recommend that you get your ITO to help you make sure that that's set right once you do a new build. So that's kind of what it's looked like here. And then we just had to fool with the color curves a little bit. But the websites are very easy to use. If you, there are 2 versions. There's an older version called flash.ou.edu. And you can get all those fields. There's a little product selection area here and a drop-down menu. So you do select that, but then you have to hit submit refresh. So it's a little clunky when you're using it, but you do have some control with your overlays, and you can set a loop to display automatically. And you have to draw a little box to zoom in. Oops, and it did that. And again, hitting the submit refresh is a little bit clunky at times. But one of the really nice things about this is that you can go back and look at past events. So if there was an event that maybe caught you off guard, go back and look at the fields that Flash generates and see if maybe there was something that, you know, may have helped you that you could use in a future event. There is a new version of Flash, flash.ou.edu/new. And again, it's a lot easier to use. In fact, you just select the product that you want to look at here. It pops it in automatically. You can just use the plus to zoom in and out. But you do have to manually step through the images. So if you want a looping image, you just use these steps up here. You can go back maybe several months, select a date, and display that data and look at it there. And one thing we did learn when the government was shut down, that since this is contracted, that it eventually quit working during the shutdown. So that was unfortunate. And just a couple of future developments coming down the pike. The model will start using QPF. Right now it just uses QPE. And they're also going to start generating some probabilistic flood products, and they're going to do a probability of flash flood LSR based on the information there. And they're also going to probability of exceeding a stream flow of 200 cubic feet per second. Or with the unit stream flow on the web, it would show up just as 2 cubic meters per second. And there is some really good training available on the CLC. If you have not had a chance to do that yet, I highly recommend it. They do occasionally run some test beds at NSSL. Steve Martinitis and JJ Gurley are the main developers, and Jill Hardy and Justin Gibbs at WDTD are the main people doing the training. And here are the websites if you'd like to visit those. Highly recommend it. And that is all I have. Do you have any questions? I know that was pretty fast, and you're welcome to email me directly.